And I started the experiment, which would become the first evidence for associative learning in plants with peas. And of course, the associative learning is a higher level of learning that is based on someone experiencing and learning to associate things. And the famous experiment of this kind of learning, you would all know it, is the famous Pavlovian dog. This is actually not Pavlov's dog, that's my dog, Picasso, who is way past associative learning, so it's quite embarrassing actually for me. I keep learning from him rather than the other way around. So just to give you a brief recap of the concept for the Pavlovian learning, Pavlov presents the dinner to the dog and the dog salivates, and then there is this famous bell that doesn't really do anything because the dog doesn't care and it doesn't mean anything to the dog until Pavlov presents the bell and the food together for a few times. And quickly the dog realizes like, when the bell rings, food is coming. And after a while, the bell alone, even if there is no dinner anywhere, instigate the salivation in the dog, and the dog is kind of expecting dinner to arrive. So, of course, this ability requires that the dog is able to detect the signals, to discriminate and categorize them, and all these abilities are based on some sort of internal system of values, which means that there is a subjective someone there, which of course with a dog now it's easy for us to connect with, that is feeling and experiencing. And of course, in this case, imagine just at the end, the bell, there is no food inside, but the bell alone, which actually doesn't mean anything really, it's not going to be any tasty if the dog tries to eat it, but the presence of this cue that is now being learned and associated with the food is extending the perceptual field. So it's informing of something that is not in the immediate environment. And in a way, that means that the dog is kind of like going across different spaces and different times. So it's an interesting thing to think about. Now, of course, what do you do when, it's easy to think of a dog doing this, especially if you have a dog as a pet. But what do you do if it's a pea? Well, you do exactly the same. The dinner for the pea is the blue light, and we know that seedlings, and particularly young peas, are very attracted to blue light, and this is a normal phototropic response. And then instead of the bell, I used a little fan, and just like the dog with the bell, my pea plants were like, I don't care about this, it doesn't mean anything to me, until you put the fan and the light together. And just like for the dog, the fan alone, after a few reiterations, the fan alone is instigating the pea to move towards it. And in this case, just like with the dog, the pea is expecting the blue light to arrive. So he has learned to associate the two cues. So just like the dog, the plants must be able to detect, discriminate, categorize according to an internal value system, which implies that there is a subjective someone that is feeling and experiencing. And just like the dog, this experience is extending the field of perception across time and space. So what did I learn out of this, aside from, a very cute science experiment? Well, the feeling body is the site of the learning for scientific methodologies. And I'm saying this because this experiment and all this entire presentation wouldn't be here at all if there wasn't an extra little ingredient. So when I did this experiment, I did a few weeks of piloting, obviously. And once I thought, okay, everything is set, yeah, everything is working according, like technically everything is there, but it's not happening. So two things. One, what an idiot. I thought a plant told me how to do my experiment. Yeah, that's right. And now I actually did that. I followed as if it was for real. Of course it's not happening. What a stupid thing to do. And then there was another moment of, because this experiment was done in complete darkness and in freezing cold temperature for my standards. And I went into the room after a few weeks of failing, to dismantle the entire thing. And then something else in that moment when I was in that room, just before I turn all the lights on and I dismantle everything, says, wait one more second. And so I'm there. Okay. And then I was invited to look into my experimental setup one more time. And something which I cannot really explain, something as I looked in changed my eyes. And I could see, and I was like, oh my God, not only this is happening and this is working, and the plants are actually showing me that they can do this kind of learning, but they were doing it all along, and I could not see it. The importance of this is that a few seconds before that moment, I was like all my other colleagues that are laughing at me right now, say like, associative learning in plants, stupid, that's not possible. And then a second later, something has shifted, something has changed in my perceptual field, in my engaging with the body into the space, which allowed me to enter a space that wasn't available before. So the attention was of the second kind. The attention that I'm talking about was the poetic attention, of feeling and experiencing and being there. And until a second before, I was trying to be the objective scientist who is not there really. The feeling body is not there, but it is. And that is what actually saved this experiment, which then, of course, was like several months of work, but it ended up well. So if you think the plant teachers are, wow, that's cool, well, there is a following step on the path to devotion. So the first, for me, was to learn how to shift attention from one mode to another, and how to acknowledge the feeling body in the space and the role that it has in the making and construction of science. But plants can also be witnesses to our further transformation. And in this case, the plant that is involved is the pea plant. And the experiment was done more recently with a colleague, which I really need to honor and acknowledge, Christy Onzik, who is a young ethnographer. And because of her, I was able to ask different questions, which speaks again to the power of true inter-cross-disciplinarity. So the question that we ended up asking together, which on my own I don't think I would have ever had the courage to really ask, is like, how does a scientist, in that case was me, come to make sense of feeling and knowing through the paradigm of a PE learning in a particular configuration, which, by the way, then kept shifting on us. So how do you use your feeling and knowing in that context to do science? So we first built, that's Christy, we first built some four-way mazes. The mazes were pretty simple, 4 arms on a piece of perspex, which is transparent. Then we put the pea in the middle. The pot is actually cut open at the bottom so that the roots can come out. And then we cover up with soil, and the entire thing goes on top of a foam box, empty foam box. And inside, there is an infrared camera that is looking upwards so that when the root of the pea hit the perspex, we can follow what the root wants to do. And whether it's exploring the space, is deciding where to go, whatever it needs to do. So in this case, again, is the journey that we are trying to observe rather than like, yep, went to the left, yep, right. Instead, it's like, is the root knowing already what to do straight away? And the truth is that, you know, I won't show you all of this, but the truth is that some go crazy and they start exploring all over and then they don't even make a decision. And others, like this one that I'll show you because it's nice and neat, seems to like, oh, I know exactly where I'm going. So you get that version. So this is how, I apologize for a little bit of blurriness. It's an infrared camera, not the best quality. So this is how the camera is seen from underneath. And the green dotted line represents the area where we are expecting the root to come out. And the red dot, in this case, represents the place of the cue, where we place the cue in the maze. In this case, the cue was the sound, the recorded sound of water, which is based on work that I've done before, knowing that the peas will know how to hear that and follow that cue. So if we fast forward, this was time-lapsed, but I just grabbed some little time shots. So here is the pea root coming out, all exciting. Of course, we're not seeing any of these until the end, but the camera is watching. And then if we fast forward a little bit more, oh, the root is going into an arm, and it looks like pretty neat. It's like, yep, I'm going that way, which it just happened to be the arm where the cue was. And how exciting, this experiment is gonna work really well. And then something else happened. The unexpected, which actually makes this experiment possibly the most confusing and yet the most powerful experiment I've ever made. So what happened was that we found that all pea plants in their own individual mazes are actually making the same decision. And like, great. I mean, isn't that like almost like the ideal science, 100% response to a cue? Well, unless the cue is something, but it's not the thing that you told them. So all of the plants seem to go to the same direction within the space, regardless of where I put my cue. And not only that, but when you look, imagine trying to work out in a room like this, what is the cue that the plant is actually responding to? I tried, of course, got frustrated, then totally depressed. And then thanks to Christy, it was like, wait, the plant is actually, you wanted to test decision making? Well, the plant is showing you, yeah, of course I can make my decision. It doesn't have to be the same as your decision. And so I was like, okay, so what do we do with this? I do not know what is the cue that the plant is responding to, and I had to accept that probably I cannot know. What they were showing us was a collectively oriented behavior, so all in their own individual mazes, but all kind of making the same decision process. And the decision is something that I don't know and I cannot control for. The quintessential horror for a scientist, especially experimentalists. But I need to know what I'm controlling for. No. This knowing that is so desperately core in science is because it's given as a fact. And it means that you are finally, what a relaxing space to be able to exclude all other possibilities and just look at one at a time or a couple at a time. It feels good. Experimentally, it makes life so easy. But that's not life. So what the peas actually were forcing me to acknowledge, it was that there are new possibilities that I didn't consider, that I couldn't consider, that I couldn't imagine at the start. And so they were inviting us, myself and Christy in that case, to slow down. Because I was freaking out. I was like, oh, I can't do this. It's like, slow down. And feel around. Again, the body entering the picture. Feel around for new possible conditions. If this room is not allowing me to understand what decision is being made there, then let's change the room. Let's change the space. Let's reconfigure the relationship between bodies and space and apparatuses, like the material that we use. And so we did that. Everything changed. And we ended up actually going even outside, building a greenhouse, and then reshuffling everything. And this is a science of not knowing. I know, it's not easy. It requires much more time, much more patience with the self, much more attention, or I would say a different kind of attention, and trust. And the trust here is in the other, in the non-human other. The plants did answer my question. Can you make decisions? Oh yeah, we can. Just, we're going to show you how. And it's not necessarily going to be how you set up the site for our bodies to express. So can we work with our bodies in space together? And they had to, I call them witnesses because they knew exactly what they were doing. I didn't. So they were witnessing me in my transformation of having to reconfigure my positioning in the space and in the relationship. So new possibilities are not discovered, they are encountered.